All right, we're going to do some problems here from looks like graphing radical functions, either square roots or cube roots. And what we really need to do is know this chart. Okay, so at some point you come to grips with this chart where you see this parent graph up here, the square root graph. Now this chart is only for the square roots. It doesn't really matter for this section. If we add on the outside, it's going to make that parent graph go up. So add on the outside, go up. Subtract on the outside, you're going to go down. Okay, so going on the outside of a function tends to make it go up or down. If you add on the inside, you're going to go left, which may be a little opposite of what you think, but it does go left here. This should say subtract on the outside. Let me fix that. Subtract on the outside. Subtract on the inside, rather. It's all messed up. Subtract on the inside. There we go. You're going to go to the right. Okay, so again, add outside up, subtract outside down, add inside left, subtract inside. You're going to go right. So we'll use that to look at this section here, this problem set. And regardless if you have this actual worksheet, this could still be helpful. So looking at a couple examples that I'm going to make up here, we could have some scenarios where you're just doing one shift. So this shift, if you remember, adding on the inside is going to make it go to the left 3. Okay, add on the inside makes it go left. We could have 2. You could have 2, something like x minus 6 minus 1. Again, by saying left 3, I mean left from where the parent graph would be. Well, this one is going to go right 6 and down 1. As a matter of fact, what a lot of times people will do here is make a coordinate, sort of a starting point here of -3, 0 by changing the sign on the inside, but doing nothing on the outside. And here we only have an inside number, the +3, so we change it to -3. We don't have an outside number, so it's just 0. But here, doing that same technique, change on the inside, but don't change on the outside. We have the point 6, -1, 6, -1. So naturally, if you think about a coordinate 6, -1, where's that located? Well, it's located to the right 6. It's down 1. Okay, so that matches what we had here. The problem asked, describe the transformation. So sort of crudely here, it goes left 3. More technically, it goes horizontal left or horizontal shift 3. This one goes right 6, down 1, or you could say horizontal shift 6, vertical shift down 1. Okay, so that's the shifts. The second part of a worksheet, if you have a worksheet and listening along here, you've got 7 through 12 where it gives you all these terms: shrink, stretch, reflection in x-axis, or reflection in y-axis. Okay, now we're only going to use the vertical stretch and shrink for this video. There is a horizontal stretch and shrink, which we're not going to cover here. But the vertical stretch, you can see, if you multiply by a number larger than 1. So I'm going to add that in here. Multiply larger than 1. More accurately, it's a absolute value larger than 1, then it's going to steepen or narrow. We call that a vertical stretch. Meanwhile, if you multiply by a number that is between 0 and 1, it's going to be a vertical shrink. And sometimes you see the word compression there. But a compression is going to flatten the parent graph. The parent graph goes somewhere in between the stretch and the shrink. Notice that when you multiply, you do not actually move the graph. You only change its steepness. If you put a negative on the outside, it's going to flip it upside down. It's what we call reflection of the x-axis. If you put a negative on the inside, it's going to flip it backwards or flip it sideways. We call that a reflection in the y-axis. All right, so looking at some examples there, I'll erase on my hand here. Let's say, just to exercise that, a third example that I'm doing, y equals 2, and it could be cube root. We'll keep everything square root here for this sake. This will be a vertical stretch. Okay, this would be a situation where you are stretching or making the graph more steep. This, meanwhile, is two things. It's both a vertical shrink or compression, according to the chart. You just really need to know the chart. You got to take some time to study the chart. There's a vertical shrink. It's also reflection. Remember, on the inside, a reflection in the y-axis. Okay, so that graph, and for this purposes right now, we're only telling the transformation. We're not actually graphing it, but we'll see that later. Now be careful. If you have a negative, let's say we have a negative 4 square root of x. It's real easy here to say, oh, 4 is less than 1, therefore it's a shrink. But it's only the absolute value of that. The negative is sort of its own thing here. So this 4 is larger than 1. We look only at the 4, not the negative 4. That is, we look at the absolute value of the number. So this would be a vertical stretch. And again, I realize that negative 4 is less than 1, but 4 is greater than 1. So it's a stretch. And this is a reflection on the outside, a reflection in the x-axis, because I'm multiplying on the outside. Again, study the chart. Pause the video and look at the chart if you need to. That's very important in this section. If you have the worksheet, we'll glance at 13 through 18, which is a combination of all the ideas we just talked about. All right, so just looking at a couple of quick examples here. Let's say that, flip the board here. Let's graph side. Let's say for my sixth example, I guess? Yeah, my sixth example. We just do something like y equals 2 square root of x minus 4. Okay, this is the combination. This is 6. This is a vertical stretch. Again, you're multiplying by a number larger than 1. It's also a shift down 4. If you want to say a vertical shift down 4, that would be fine. Now, a word of caution here. This is a little bit of a, I guess you could call sort of not an exception, but something to watch out for. If you have a negative like this, okay, so be careful. What you want to do first, if we can read this, okay, that's negative x. You want to take that negative out of there. So let's take the negative out, away from the rest of the inside of the function. So would you agree that if I took a negative out, it would be x minus 4? Okay. The reason I say that is when you reflect in the y-axis, the negatives is to the entire inside, not just to the x. So this would be a vertical shrink thanks to the 1/3. It would be a reflection in the y-axis, and it actually would go right 4. It originally appears that it would go left because of plus, but when you take the negative out, it becomes minus, and it's going to go to the right 4. So you need to be careful in that case. Okay, so that's the first 3 sections of our